So this is an overview of the ImageNet dataset training model training that we did. So let me walk you through the repository that we have created and the steps that we have taken. So this is our repository. You can find it here. So we started with initial ablation runs on tiny ImageNet dataset because we have to remember that the actual ImageNet dataset is quite huge, 160 GB dataset. So you can't actually run it on Colab, and the hyperparameters and the techniques that you are going to use, you have to essentially understand them using ablation runs on a much smaller data set, which is kind of representative but not the same as the ImageNet data set, right? So here you can see we have done ablation runs, and you can find our ablation runs in this ablation runs folder. So all the notebooks are present here. So coming back, so we did ablation runs on tiny ImageNet dataset. Here, what the conclusion that we reached it, we use a ResNet50 with con layer instead of fully connected layer. We use mix precision training, mix up and cut mix for data augmentation. We also used a technique called progressive batch resizing, where basically we progressively increase the batch size of the image while we are training. We use a technique called as stochastic depth, where based on a parameter, some of the layers of the model are randomly dropped during training. We also experimented with exponential moving average, but this technique did not turn out to work for us, and so we did not use it in the final model. Plus, we also used another technique known as blur pool, right, which again leads to a much robust model. So the actual ImageNet training we did on a single GPU machine. This is essentially the command, and can run the train.py with this command. We have also included commands for training with multi-GPU training, but we could not get a spot instance machine with multi-GPU allocated, so we could not train on that. But nevertheless, we have included code for doing that. Then there is a learning rate finder code which you can use to find the learning rate. We have also listed our learning rate configuration that we use. We did a training of around 110 epochs. It took around 36 hours of training time. This is the ILSVRC ImageNet dataset folder for reference, which can be referred to. One of the challenges that we faced is like downloading the ImageNet dataset. So for that, it's a very big dataset, 160 GB. So what you have to do for that is you have to create an EBS volume on EC2. So you can use a 350 GB volume. And then using a Windows instance, basically we found that we could, download it through a browser, uh, and there is a download manager that we have listed, which makes it much faster. So with that, we could download it in under 1 hour, right? The entire data set and unzip it. We use a G5 2x large instance, spot instance for our actual runs, right? So you can see the details of how we set it up in the repository. And our training essentially was divided into four phases. So phase one, which was epoch 1 to 15, was trained using 128 cross 128 size images. The phase 2, which was the longest, uh, was between 16 to 80 epochs, which we trained using 224 cross 224 cross image size. Then phase 3 with a slightly larger 288 cross 288, and final phase, which is phase 4 with 320 cross 320 with a batch size of 64. So this was how we trained it. And for phase 3 and phase 4, we actually disabled mix up and cut mix and stochastic depth. So this was based on the guidance in fixed res paper. So we followed that guidance. So it's called a fixed res technique, where you fine tune on a slightly higher image size by disabling all the augmentations, right? So yeah, so this is our basic recipe that we did, and you can see the other parameters. We also use label smoothing, gradient clipping, mixed precision training with grad scaler to speed up the training process, and we also use blur pool. But these parameters are configurable in our training setup, so you can also try with a different configuration. For optimizer, we use Adam W, weighted Adam, uh, with a weight decay parameter of this, and we use a one cycle scheduler, right, for as optimizer. You can see the training process screenshots, right? And finally, we deployed it on Hugging Face spaces. Uh, so you can read about that as well in the repo. Going to our actual deployment, so we achieved accuracy of around 71%, but we think it's a robust classifier. So let me show you some cases. I will try to upload some images. Uh, I will pick some validation images. So it has classified it as a sea snake. Let me try with a few more. Let us try this one. Let's try this one. So it has classified it as a ski. Try one more. What is this? Okay, let's check if it is able to find this out. Okay, so it looks like a porcupine. Yeah, it's porcupine. Let me try one more. More random image which I downloaded. So, tiger. I know that it's tiger. Let's see if it's, and it's a smaller image size. So let's see if it's able to identify it. Yeah, so with 100% accuracy, it's finding it tiger. So yeah, so this is the deployed model, and you can access and test it. That's a brief summary of the project that we did. Hope you enjoyed the presentation. Thank you.